Okay, so what we're going to be doing here is proving the law of sines. So the law of sines, what it says is that for any triangle ABC, so the vertices are capital A, capital B, capital C, if you take the sine of A, so the sine of angle A, and make a ratio of that number over little a, that ratio is going to be equal to the sine of any of the other vertices over their opposite sides. So that's basically what it says. Now, the question is, how do we prove that? A little bit of algebra in here. What I'm going to do is I'll go ahead and do like we generally do here. We take this side, right? And we can show that it's a right angle. We're going to drop an altitude, which is a line, a perpendicular line to one side up through the opposite vertex, right? And we usually call the altitude of a triangle the height, so we'll call that h. So basically, let's just use our regular definitions. So let's talk about what the sine of A would be here. What's the sine of A going to be equal to? Well, it's a ratio, right? So we know that it's opposite over hypotenuse. So it's going to be h over b, right? So now let's talk about what the sine of b would be. What would the sine of b be equal to? Well, that's going to be from b the opposite over the hypotenuse. So that is going to be h over a. So now what we're going to do is we're going to solve for h, right? The way we do that is we multiply both sides over here by b, right? And these are going to cancel. So we're left with, so this is where we multiplied, we're left with b times the sine of a is equal to h, right? Because if I multiply by b, that cancels this divide by b. So I bring it over here and multiply by b on this side. So h is just equal to b times the sine of a. The height is equal to the side times the sine of a. We know that. And guess what? I mean, the same logic holds true for the other side, right? I can multiply by a here, both sides. So h is also equal to, right? Because these will cancel, and what's left is h is equal to a times the sine of b. Okay, so now all we're going to do is we're going to say, hey, if this is equal to h and this is equal to h, then guess what? They got to be equal to each other, right? That's the transitive. So by the transitive property of equality, we can say these guys are now equal to each other. So here we go. We have b times the sine of a is equal to a times the sine of b. Oh, this isn't so bad. All we're going to do is divide both sides by a and divide both sides by b as well. So what's going to happen now that I've divided this side by a? Well, that's going to cancel, right? It's going to cancel. And I'm left with sine of b over the measure of side b is equal to sine of a over the measure of side a. Hey, which is exactly what we were going to prove. So we're not even going to repeat the logic. I don't have to repeat the logic because it'd be simple enough to do, but A, B, and C were just generic sides. But the same holds true. If I had drawn my altitude here, we would have said, you know, C, we could have proven that C, we could have done the same thing for C. Okay? So that's really what we know, that the law of sines, or that's really how we can prove, and that is your proof of the law of sines. Now let's take a moment and see how that can be useful. All right? if I had a triangle, just draw something out. Actually, you know what? Let me switch over to GeoGebra and we'll do one over there. Okay, so when is this useful? When would this be useful to me? Well, when it's going to be useful is when I know some angles, right? I have to know, well, let me actually write this out, okay? When it's going to be useful. It's going to be useful whenever I have, I'm going to see if I can write with my mouse. This might not be good. I'm going to have 3 of 4 parts, right? That are in the ratio, right? And so it would be helpful for me to solve the 4th part. So what are the 4 parts? I have one side, right? I have the second part would be, oh boy. Okay, sorry. The second part is going to be another side, right? And then the third part is going to be an angle. And the 4th part is going to be an angle. So let's say that I know 2 sides and an angle. And that's all I know, and I want to solve the rest of this triangle. When we say solve a triangle, it means know all the parts of the triangle. So I'm going to measure 2 sides. Let's do that here. I'm going to say that I have this side here, and the thing is, I've got to have one of my angles is going to have to be an angle that's opposite one of those sides, right? So we've got 2 sides and an angle that's opposite one of those sides. Okay, so there's an example of a problem, and it might come out and say, solve this triangle, which means find that side and find this angle and that angle and all the angles, okay? So we'll work on that here in a second. If I have enough time, we'll get all that done. But I'll at least just show you how we could at least find this angle and that angle real quick, and we'll worry about the 3rd side maybe later on. Okay, over here, actually, let's do that and then see if we have time for all these triangles. Okay, so what am I going to do? Well, I'm going to use the, maybe I will just type because writing is not working so well for me here. So what am I going to do? I know that the sine of an angle divided by the opposite side is equal to the sine of another angle divided by its opposite side. So in this case, right here, I'm going to take the sine of 21.03. So sine of 21.03 divided by the opposite side from there. So the opposite side is this one, 4.42. And I'm going to say that that is equal to the sine of, well, the only other ratio I can make that I'm missing a part of is this angle right here. See, I have the opposite side, but I don't have this angle. So we're going to find this angle right here. So the sine of capital B, and that is going to be divided by 3.72. So just thinking with some algebra here, what would I do? I'm going to solve for the sine of B. I'm going to solve for the sine of B, and the way that I do that is I'm going to have to multiply both sides by 3.72. So we'll go ahead and do that. And so I go 3.72 times the sine of 21.03 divided by 4.42 is equal to the sine of B. Now, how would I find B? I have to take the inverse sine of this side of the equation, and guess what? I'm going to take the inverse sine of the opposite as well. So I would go like this. Inverse sine, that's sine, I'll just put -1, so you can see I'm doing the inverse here. Actually, we'd do the arrow to say superscript -1. All right? Yeah, that's okay. I'm going to put up -1 so you can see that correctly. Times, of 3.72 times the sine of 21.03 divided by 4.42. Close that out. That's what we're taking the inverse sine of, and it will be equal to B, because we have taken the inverse sine of both sides, so that would cancel. We just have B. So let's put that in the calculator here. I'm going to flip over, turn this on. Okay. see if I can get this done here. All right, so first we have to put the inverse sine function. So we go inverse sine of what? Well, it was 3.72 times, then we had a ratio, right? So control divide. So we can make a little fraction there. And we're going to put on the top the sine of 21.03. So we'll go the sine of 21.03 and then put that over the opposite side, which was 4.42. And that will be equal to B. So B must measure 17.5792. Did I do that right? That doesn't look right. Oh yeah, that could be a 17.5792 angle. Well, let's confirm. Here we go. Is this 17? Oh boy. Let's try that again. And here we go. Is this 17.59 whatever? 17.56. Very good. Off a little. I had 17.57, almost 58. I'm off, and the reason I'm off is because of the rounding that I did right here. This is not exactly 21.03. So you can see that rounding is your enemy. It gets things kind of off a little bit. You can only get so accurate once you start rounding. So you try. That's why I don't take the sine first, because then I would have had to round that too, and it would get even worse, okay? So there is our solution over there. That's how we did that. Now that we know these two angles, guess what I could do? I can find the third. How do I find the third? I take, well, maybe I can go back in here. What do? I take 180. So I go 180 minus 21.03 minus 17.56, and that is equal to, there we go, 180 minus 21.03 minus, and I'm going to put the exact number right there, 17 point, oh, wait a minute. It was 17.56, we'll call it. 17.56. That's not exact actually either, but 141.41. So now we've solved this angle. We believe this is 141.41, right? That's what we believe, knowing that the rounding is off a little bit, but let's go ahead and measure. We will measure that angle. 1, 2, oops, thought I had the measurement tool. Here we go. 1, 2, and we see, hey, we were able to solve that second angle pretty good. All right, how would I find the third side? Well, this is actually not too bad. We're going to find the third side because we're going to do this. We're going to say that we know, we'll use the ratio again. We'll use this ratio of this angle and the opposite side and solve it, just like, because we have three parts now, right? I can do this side or this angle and the opposite side. So the sine of this over that is equal to the sine of this over that. So let's do that. Here we go. So we go sine of 21.03 divided by 4.42 is equal to the sine of 141.41 divided by, and we'll call that side little c, right? So if we want to solve by c, we multiply both sides by c. So to get it out of that denominator, so c times sine, I'm getting stressed about time, 21.03, close the parentheses, divided by 4.42 is equal to the sine of 141.41. Now how do we solve? We are going to inverse this fraction and multiply by the inverse, which the reciprocal, which would be leave c by itself, is equal to the sine of 141.41 times 4.42 over the sine of 21.03. Oh boy, I better hurry. Let's put that in the calculator fast. Here we go. I've got sine of 141 and I'm going to pause this and I'll show you. Okay, so I took that, can put it in here, sine 141.41 times the inverse, and we got 7.68258, and let's measure that side. Come on, I'm out of time. length is